Greetings of the day. I am Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. Today's topic is Tooling for Chemical Milling. I am the Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Right. This is the course learning outcome of the today's topic. Okay. So by the end of this session, student will be able to understand the basic procedure for chemical milling and its tooling. Okay. So this is the course learning outcome of the today's topic. Right. Now let us discuss the various categories of the non-traditional machining process. Okay. So we have three major categories under non-traditional machining processes. First one is mechanical, second one is thermal, third one is chemical and electrochemical. Okay. Now let us see. Under mechanical we have ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Under thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. Under chemical and electrochemical, chemical milling, photochemical milling, electrochemical milling. Now we are discussing chemical milling process. Right. Now let us discuss the tooling for chemical milling. Tooling for chemical milling is relatively inexpensive and simple to modify. Okay. There are 4 different types of tools are required. Okay. First one is maskets, second one is etchants, third one is scribing templates, fourth one accessories. Okay. So let me reiterate these 4 different types of tools for the chemical milling. First one maskets, second one etchants, third one scribing templates, fourth one accessories. Okay. Right. Now let us look at the first type. Okay. Out of 4, maskets is the first one. Okay. Maskets are generally used to protect parts of the workpiece where CD action is not needed. Okay. So here chemical dissociation is not required over the some portion of the surface of the workpiece. Okay. So let us say this is the workpiece, this is surface. Let us say in this area we do not want some chemical dissociation. So where we have to apply the maskets. Okay. So in the rest of the area the chemical reaction will take place. So usually synthetic or rubber based materials are frequently used for these maskets. Okay. So maskets is nothing but a mask. Okay. So this mask will protect the workpiece where we do not want any material removal. Okay, because of this chemical action. Okay, right. Now from table 1, different maskets and etchants for several materials together with the etch rate and etch factor. Okay. Now table 1, muskets and etchants for different workpiece materials. Okay, so let us see workpiece, etchant, musket, etch rate in millimeters per minute, and etch factor. Okay, now let us look at the various workpiece materials: aluminium, magnesium, copper, steel, titanium, nickel, silicon. Okay, so for aluminium, the etchant is FeCl3. Okay, whereas chloride. Okay, and NaOH, sodium hydroxide. And for magnesium, HNO3. For copper, FeCl3. Okay, and CuCl3 also. Okay, but for steel, HCl, HNO3, FeCl3. Okay, for titanium, HF and HF-HNO combination. For nickel, FeCl3. For silicon, HNO3, HF, H2O. Okay, so these are the etchant materials for different workpiece materials. Okay, and let us look at the musket. Okay, what are the materials associated to this musket? Okay, when workpiece is aluminum, the musket is polymers. Okay, for magnesium, it is polymers. Okay, when the etchant is NaOH. Okay, when the etchant is HNO3, we have to use polymers. When the etchant is FeCl3, we have to go with polymers. Okay, and when for steel, when it is HCl, HNO3, we have to go with polymers. For titanium, when we use HF is the etchant material, the musket material is polymers. But here, for nickel workpiece material, and when the etchant is FeCl3, we have to go with polyethylene. Okay, and for silicon, HNO3, HFH2O etchant material, we have to go with polymers. Okay, so only here we find polyethylene. In the rest of the cases, the musket material is polymers. Okay, now etch rate. Okay, so here we can discuss all these etch rates and etch factor when we discuss the next item. Okay, so far we are focusing on the musket. Okay, so here we have different musket materials for the various workpiece materials and etchant materials. Okay, right. Next, muskets should, however, possess the following properties. Okay, muskets should have some properties. Okay, first one, be tough enough to withstand handling. Okay, be tough enough to withstand handling. Second one, adhere well to the workpiece surface. Otherwise, what will happen? The purpose will not be solved. Next, third one, scribe easily. Otherwise, the purpose will not be performed as per our requirement. Fourth one, be inert to chemical reagent used. Okay, it should not react with the chemical. Okay, what we are using. Okay, Next, be able to withstand the heat generated by etching. So usually while the etching process is performing, it dissipates some heat. So it should be able to withstand the heat generated. Okay. Next, be removed easily and inexpensively after etching. So after etching process, we should be able to remove that musket very easily without damaging the workpiece or without deteriorating the very minute corners of the workpiece surface. So these are the following properties which the musket should have. Okay. So once again, let me reiterate quickly. Be tough enough to withstand handling. Second one, adhere well to the workpiece surface. Scribe easily. Be inert to the chemical reagent used. Be able to withstand heat generated by etching. Be removed easily and inexpensively after etching. Okay. So these 6 are very much important properties of the muskets. Right. And moreover, multiple coats of muskets are frequently used to increase the etchant resistance and avoid the formation of pinholes on the machine surfaces. Okay, so here multiple coats of muskets are frequently used. Okay, to increase the etchant resistance and avoid the formation of pinholes on the machine surfaces. Okay, right. Next, when thicker, rougher, dip or spray coatings are used, deeper cuts that require long exposure time to the etchant can be achieved. Okay, so those are dip, brush, spray, roller, and electro coating. Okay, adhesive tapes can be used to apply masks. Okay, when thicker, rougher, dip or spray coatings are used, deeper cuts that require long exposure time to the etchant can be achieved. Okay, so these are the following techniques or tools: dip, brush, spray, roller, electrocoating, adhesive tapes. Okay, can be used to apply masks. Okay, right. Spraying the mask on the workpiece through silk screen on which the design is imposed combines the masking application with the scribing operation since no peeling is required. Okay, so spraying on the mask on the workpiece through silk screen, here silk screen, okay, on which the desired design is imposed combines the masking application with the scribing operation since no peeling is required. Okay, so without peeling, it can be performed with the silk screen. Okay, right. The product quality is therefore improved as the ability to generate finer details. So with silk screens, we have good quality of the product. Okay. However, the thin coating layer applied when using silk screens will not resist etching for a long time as will the cut and peel method. Okay, so here sometimes cut and peel method is good, sometimes by using silk screens will be better. But here the thing is that when we go with silk screens, the quality will be better. But the thing is that for thin coating layer applied when using silk screens will not resist etching for a long time as will the cut and fill method. Okay, so problem with the silk screen when we go with thin coatings. Otherwise, it will be better in terms of quality and finer details. Okay, right. Photoresist masks which are used in photochemical milling. Okay, photochemical milling. In short, it is PCM. Also combine both coating and scribing operations. Okay, so here we are combining coating and scribing operations in photochemical milling, that is PCM. Okay, so in photoresist masks which are used in photochemical milling also combine both the coating and scribing operations. Okay, the relatively thin coat applied as dip or spray coats will not withstand rough handling or long exposure times to the etchants. Okay, so this is important point. Okay, what it means, the relatively thin coat applied as dip or spray coats will not withstand rough handling or long exposure times to the etchant. Okay, so when it is rough or when we go for long exposure times will not be withstanding. Okay, for about thin coated sections. However, photoresist mask ensures high accuracy, ease of repetition for multiple part etching and ease of modification. Okay, photoresist mask ensure high accuracy. Okay, ease of repetition for multiple part etching and ease of modification. So these are the important features of the photoresist masks. Okay, the accuracy obtained for lateral dimensions depends on the complexity of the masking. Okay, so here lateral dimensions means across the width. Okay, the accuracy obtained for lateral dimensions depends on the complexity of the masking. Okay, right. Typical tolerances for the different masks are as follows. For cut and peel masks, the tolerance be plus or minus 0.179 millimeters. For silk screen resist, plus or minus 0.077 millimeters. For photoresist, the tolerance is less or minus 0.013. Okay, for photoresist, the tolerance is less or minus 0.013 millimeters. Okay, so it is very close dimensional tolerance. Okay, right. Now etchants, second one. Okay, first one mask and over. Now we are discussing the second important type, 2 out of 4. Etchants. Etchants are acid or alkaline solutions maintained within a controlled range of chemical composition and temperatures. Okay, now at this stage let us discuss the etchant rate and H factor with respect to the workpiece material and etchant material. Okay, already we have covered the mascent material for these workpiece material and etchant material in the previous slides. Okay, now let us focus on the etchant rate and etch factor. Okay, right, for aluminium the etch rate is 0.0132 to 0.025 millimeters per minute. Okay, similarly for NaOH the etch rate is 0.0202 to 0.030. Okay, for HNO3 for the material magnesium the etch rate is 1.0 to 2.0 millimeters per minute. For FeCl3, okay, for the copper material the etch rate is 2.0. For the same copper material, when the etchant is CuCl3, it will be 1.2. The etch rate is 1.2. But however, here we can see very close etch rates. Okay, in terms of millimeters per minute for steel and titanium with different etch materials. HCl HNO3 it is 0.025 millimeters per minute. For FeCl3 of the steel material also it is 0.025, 0.025. Okay. For titanium workpiece material and HN material the etch rate is 0.025 millimeters per minute. Okay, see how close it is. Okay, again for nickel workpiece material and FeCl3 as the HN material, the etch rate is 0.13 to 0.038 millimeters per minute. For silicon, it is very low. Okay, again when we discuss etch factor for the following workpiece material and HN material, it is ranging from 1 to maximum 3. Okay, so for the aluminum it is 1.5 to 2.0. Okay, for magnesium it is 1. For copper it is 2.5 to 3.0. For steel it is 2.0. For titanium it is 1.0. For nickel it is 1.0 to 3.0. Okay, right. Their main technical goals are to achieve the following. Okay, good surface finish, uniformity of metal removal, control of selective and intergranular attack. Fourth one, control of hydrogen absorption in case of titanium alloys. Fifth one, maintenance of personal safety. Okay, so these 5 are the important goals. Okay, first one, good surface finish. Second one, uniformity of metal removal. Okay, so there should not be any uniform metal removal, and at the same time the surface finish should be good and as per our expectation. Third one, control of selective and intergranular attack. Okay, so we have to remove the material as per the surgical areas. Okay, we should not remove the unselective areas. Okay, next, control of hydrogen absorption in case of titanium alloys. Maintenance of personal safety. Why? Because we are dealing chemicals, so definitely there will be a chance of chemical damage or any personal damage. So we have to maintain personal safety. Next, best price and reliability for the materials to be used in the construction of the process tank. Okay, maintenance of air quality and avoidance of possible environmental problems. Seventh one, low cost per unit weight dissolved. Eighth one, ability to regenerate the adjacent solution and are readily neutralize and dispose of its waste products. Okay, suppose if it is not disposed properly, so it will harm the environment. Okay, next, third one, scribing templates. Scribing templates are used to define the areas for exposure to the chemical machining action. Okay, so scribing templates are used to define the areas for exposure to the chemical machining action. The most common workpiece scribing method is to cut the mask with a sharp knife followed by careful peeling of the mask from the selected areas. Okay, so this is scribing template. Right. Layout lines are simple templates of metal or fiberglass guide the scribing process. The H factor elements must be included in any method used for the scribing operation. And one more point is that the negative usually used in photochemical milling, that is PCM, or its layout and the template of the silk screen must allow for the degree of undercutting expected during etching. Okay, right. Now let us look at this figure. Laser cutting of masks for chemical milling for large surfaces. Okay, when the surface size is very large, let us look at this numerical control laser scribing of masks for chemical milling of a large surface area. Okay, see here the figure illustrates this is a masked surface. Okay, this is laser. Okay, capacitive position transducer here. Okay, this one. Next, we are using laser power 75 kilowatt to 400 microns thick mask that we are using. And here the setup details. Okay, we are using CO2 laser. Okay, we are applying mask over the aluminum workpiece surface. Okay, so here we are maintaining constant gap. Here air for cooling. Okay, and we are using lens for the focusing of the laser beam. Okay, for the chemical milling. Next, last one, accessories. Accessories includes tanks, hooks, brackets, racks and fixes. So these are the various accessories. Okay, what are those? Tanks, hooks, brackets, racks and fixtures. Okay, these are used for a single or multiple piece handling into and out of the etchant and rinses. Okay, so these are the accessories and the following are the references used for this presentation, and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.